Okay, so today we will be talking about func in general, trying to bring back the func to Java and Kubernetes. That basically means that we will be talking about Knative, Spring, and a bunch of other things that are related to that, how difficult it is, how easy it is, and a bunch of other topics in the meantime. I just clicked the other one. My name is Mauricio Salatino. I do work for a company that's called VMware, and I am spending my time in a project that's called Knative. How many people here in the room is using Kubernetes already? Okay, yeah, that's a good number. How many have heard about Knative before? Okay, that's good. I've been spending some time on that project. I'm quite of a fan. I'm at Salavo in Twitter if you want to follow me there. And I'm super passionate about functions, like the functions programming model, building platforms, open source in general, and I've been working with Kubernetes for some time. That's why I'm kind of like writing this book that's called Continuous Delivery for Kubernetes, and I have the pleasure to be presenting here with Thomas.
Thank you. Hi, everyone. It's really great to be here in person this year at Devox. I'm Thomas. I work for a Danish software company called Systematic. I'm a software architect there. And I'm really passionate about open source, cloud-native technologies. I'm also writing a book. It's called Knative Spring in Action. And I'm also a big supporter of open source. Whenever I can, I try to contribute to different projects, for example, Spring Cloud and Spring Security. So let's get started and have some fun. Yeah?
Yep, let's do it. OK, so we will start this presentation in a very odd way, which is by showing you a game that we have built. It's a quiz game. It's a very simple game. Let me switch there to the application. And the main idea here is that we will be playing this game at the end of the session with you folks, like a real version of this game. What I have here is just something that I wanted to show, just to give you some context about the things that we have been building and the tools that we use to build these kind of things. So it's just a basic, very, very basic quiz game where you just generate your player's name, and then you start. And because we will be talking about functions, all the functionality in the backend is being driven by functions, right? So when I start the game, what's happening now is that some function was bootstrapped, just executed some logic, and then the UI knows that it can move forward. Every time that I want to play a different level, I will have this screen, which basically will allow me to start the level, which again will kickstart another function in the backend that will be started, and then it will be driving that level forward. Whenever you are going to play a level, basically what you're going to have is you're going to have a timer with 10 seconds just to answer that question. That question, in this case, it's a multiple choice question, and you will just need to select one, and that will just move you forward. The function will evaluate the answer, and it will give you a score. Pretty simple, pretty straightforward. Then you can move to the next level. The next level will be a little bit different. In this case, you will need to press some buttons, so you will need to read kind of like what the question is or what the idea of that level is, and then just do whatever it tells you as fast as you can, because again, you have 10 seconds. If you don't do whatever you're supposed to do, the answer will be sent, and then if you do it right, you will get points. If you don't, you will get less points for sure. And finally, when the game is over, you will have kind of like one screen like this that basically shows you the final score, and it will allow you to tweet the score, basically. And if you tweet the score, then you can enter into a raffle. We will be giving away some books and some swag as well. So that's pretty much the context. Again, as I mentioned before, we will be sharing a different instance of the same application with more levels, so we can all play together at the same time, and we can see how kind of like the platform starts scaling up when multiple people start interacting with different levels. By having introduced that, we can just jump into how we built this and what kind of technologies did we use.
Perfect. So we're going to start talking about serverless architectures. So we want to build and expand upon this game project by focusing on the developer experience. As developers, we want to focus on the business logic. And that's what serverless is all about. It doesn't mean without servers, but we don't care about the underlying infrastructure. So we can identify some responsibilities for the developer and for the platform. And all we want for the developer is focus on business logic. That's what makes our products special. And then the platform takes care of the rest. It will provision the necessary infrastructure. It will manage all the different workloads, for example, on Kubernetes. And then we want to also have dynamic scaling. So we're going to see later, more people will join in. The workloads should scale dynamically. So as a developer, I don't want to deal with that. And in the past few years, we got several options and several technologies for building serverless architectures. So it's a really great landscape out there. And one particular technology we talk about today, as you guessed, is Knative. Knative has a project called Serving, which we can use to build a serverless platform on top of Kubernetes. And that brings a lot of advantages. First of all, we have developer-friendly abstractions. So we don't deal with the underlying pods, deployments, replica sets, ingresses, but we have a better abstraction for a developer and enable the experience that we call from code to URL. So we want to have very much focus on the business logic, and when the code is done, we want to get to production as fast as possible without having to deal with too many concerns. We can have auto-scaling out of the box with Knative, including scaling to 0. That enables, for example, using functions and having a real serverless architecture on top of Kubernetes. We can also get progressive rollouts because Knative provides several advanced features to implement different deployment strategies like blue-green deployments, canary releases, progressive delivery. That's built in the project. Everything is request-driven or event-driven. That's at the core of the auto-scaling. So if we get more requests or more events, then the system will scale out accordingly or scale in when there's not many requests anymore. If we have no requests, then we scale to 0, which means we are also optimizing cost, because if there's nothing to do, keeping a container alive is a waste of resources. And finally, it's cloud-agnostic, because it runs on Kubernetes, so we can run it on any Kubernetes distribution on any cloud. Now I want to show you a very quick demo. I have already built a container image that can run on plain Kubernetes, but if we introduce Knative, then we can get a new experience that relies on these developer-friendly abstractions.
Is it the terminal okay? Bigger? Is it okay? Thank you.
Yes. So I can use the Knative CLI, KN, and I can say service create. So the service is the abstraction introduced by Knative. And then I define a name. Let's say web service. A port number, 8080, and an image. I have already pushed an image on GitHub container registry, so let's reference that one. And that's it. I can do this with any kind of containerized application. So I can smoothly transition from working on a plain Kubernetes environment to Knative, even for a long-running application. So it doesn't have to be functions. But what I can achieve here is providing an image, a port number, and I get a URL. So I can directly access the application. So if I send a GET request to that endpoint, then I get a message back, welcome to London. And that's it. I didn't have to create pods, replica sets, deployments, ingresses. Everything is handled by Knative. So I can achieve this really developer-friendly experience and start by moving our containerized workloads on Kubernetes. But since we are now using Knative, we get more opportunities to further expand which kind of applications we can run. And one of them is, of course, a functional type of applications. So let's have a look at that now.
Yeah, so I think that's an important point, right? Like Knative, it's not only about functions, but it's about running any containerized application and using more features that are provided by the project, like the release strategies and and continuous rollouts and all that stuff. Functions, in the other hand, it's a completely different paradigm approach, like on how you build applications, and it's a completely different thing of just building, the normal Java applications that we were used to build, right? Like it's not the client-server thing. It's not something that will be running there all the time. Functions are a little bit different. It's a different programming model. When we talk about functions, we are talking about small pieces of code that are going to be triggered by requests or events. Again, these functions are going to be very focused on doing just a single thing very well, just very focused. They tend to be very stateless. They do not store state inside the runtime. mostly because they are going to be triggered by a request, they will perform some operations, and then they will shut down, probably. The scope is smaller, so they are easy to maintain, they are easy to evolve. They are way smaller than normal applications, or even applications when we think about having REST-driven applications with multiple endpoints. When we talk about functions, we also talk a lot about cold starts, and this is what's mentioned in the keynote, right? When we have smaller pieces of code that we want to bootstrap on demand, how fast they start is kind of like a very important factor, because we don't want to get clients waiting for the functions to start in order to be able to do the processing. So cold starts are a thing, and Knative does a bunch of things to deal with cold starts. And of course, as mentioned by Thomas, cost optimization is a thing, right? Like if we don't need a function, the function doesn't need to be there running in our servers doing nothing. We can just shut it down and just start it again whenever a request comes into the platform. When you start building functions, you will see that there are like different interaction patterns with functions, and we wanted to just quickly show some of them because I think that it's important, again, just to show the transition from a normal programming model where you are creating REST endpoints for your applications and when you are building functions. When you have functions like this, again, because the scope is pretty small, you can definitely have a fire and forget approach where you just send a request to the function does some processing, but as a client for the function, the only thing that you're interested is in knowing that the function got the request and then the function will do the thing, right? You are not expecting any response. The other approach is doing a request-response approach where you just call the function needs to run some logic, and then you are going to get some output that your application will use. This is quite normal. This is, I would say, the most used approach. If you're writing lambdas, this is something that you will do. And when you are doing these kind of interactions, you need to start thinking about how synchronous the interactions are, right? So if you send a request to a function that it's going to do some processing, but in order to do some processing, it needs to go to a database and fetch some data to do the processing and the calculations. You will be, hanging in there, like the one that is creating the request. It needs to wait for the data to be fetched to the function. The processing needs to happen, and then we can send the response back. And that will take time, right? So you need to have that in your mind when you are designing functions. There are different techniques to avoid doing these kind of things, but I think that that's kind of like a very important change. As we mentioned before, functions are going to be able to scale up based on demand, and that also means that you will need to have some kind of load balancer in there. This load balancer will be provided usually by the platform, and with Knative, that's all provided out for you out of the box. Which also means that you need to know that there will be multiple replicas, and the application sending the request might be hitting different replicas. That puts you again into that situation where if you want to share data between the different replicas, you need an external storage. And that might become also the bottleneck for this kind of application. So I think that that's kind of like another thing that it's important for developers to have in mind. But as we mentioned before, we might hit these scenarios where nobody's using our functions. That basically means that there are no containers running there. We are saving some money because we are not running our code. And that also means that from the requester point of view, there needs to be something there, like close to the load balancer, that it's going to at least buffer the requests until the functions start, and then the processing happens. That's also provided by Knative out of the box. There are some other asynchronous interactions here where you can do some very long processing in functions, and then you just send a request. You're not expecting a response back because you don't want to hang the person who is creating the request. You want to let the function do its thing, maybe spend 2 hours, and then have a way to publish the result somewhere else. So you will need to, as a developer or as a person implementing this kind of thing, have a way to know where to go and pick up those results for that execution. That's something that usually it's put on the developer that is building these kind of asynchronous interactions. There are some initiatives in the Knative project just to provide a solution for that. And then you go to the very asynchronous spectrum, which is like the more event-based approach, where basically your function reacts on events, right? And this is very common also when you're building Lambda functions or using other functions in different cloud providers, which is basically you have functions that are listening to a specific type of events. If the event happens, the function will do some processing with the event payload, and then it will emit an event out, so other function can pick it up. And you can end up doing kind of like chaining functions based on events. When you are doing these kind of interactions, you are probably building a more like an event-driven approach application. And this is really nice to build this very, choreography kind of application where there is no one defining what's the next function that needs to be called. The functions will react based on the events that are happening. And finally, just wanted to say that you can mix and match all these kind of like approaches. You can have synchronous requests, but the function can also be emitting, events to like an event router that will route those events to different places, right? And that can give you observability and reactiveness and a bunch of other things. For that, in the Knative project, we have a specific kind of like module and a specific initiative that is called Knative Functions that basically is focused on the developer experience on building functions and functional applications. For that, we have a CLI that is called func, and that's kind of like where the func part comes in, which allows us to do a bunch of different things, like, for example, scaffolding projects and in different languages. The main idea here is that because we are in Kubernetes, we are building functions, we should enable developers to pick their language of choice, so you can create and scaffold functions in any language that you want. There are a bunch of languages supported, but you can actually add any other language if you want, that it's not there. Then what you can do is you can build the function by using func build. And in this case, the idea here is that we want the developer not to worry about how the application will be containerized, to be able to execute that into a Kubernetes cluster. And for that, we are using build packs. And that basically means that we are not writing Docker files for our function projects. We let a build pack, which is another CNCF project that takes care of detecting the language of the function in this case, and then defining how to build a container for that project. Finally, you can do func deploy, which basically will deploy the function project into a Kubernetes cluster that has Knative in it. And again, there, as Thomas showed with the KN CLI, there is no YAML included. The idea here is that you can create a project, you can code your function, you can build it without writing a Docker file, and then you can deploy it without writing a single line of YAML file into a Kubernetes cluster. And I think that highly improves the experience from the developer point of view. And I wanted to quickly show you that in action here, because again, it should work. It's a live demo. I'm running this against a real cluster, so it might not work. But let's try to do it, right? Pretty quickly, right? So I will just create a simple directory here that's called Hello DevOps, right? It does exist, okay. Let's do another thing here. We can just delete it.
Yes.
Hello DevOps, let's delete that. And what I can do here is recreate the directory, probably. So we go there. That's the funny side of testing things before running, which before it worked, now it will not work, probably. So func create. We can just run this command, which basically means let's create a project using Go in this case. It's a Java track, but I will use Go because I'm a rebel. And then I would use the HTTP interaction. So no CloudEvents, just imperative calling the function. I've just created the function here in this directory. I can just list the files. I will have a bunch of Go files in there. I can use an IDE just to edit that, just to show you that it's a really simple project. In this case, just a function. And again, like the idea here is just to enable the developer to have like a very simple signature for invoking the functions. We can enable our developers just to write the logic in here and then just provide a result from the function. In this case, just a simple string. Hello from a function. Hello DevOps from a function. That's the most basic function that you can build, of course, but this is where you are going to connect, for example, to a database, get data, connect to some cloud services, and do whatever you want from there. And then I can run, of course, as I mentioned before, func build, but I will just run func deploy, which actually will containerize the application, push it to a Docker registry, and then just run that into my Kubernetes cluster. For that, of course, there is no magic here. I need to enter where my container registry is, and I will be using Thomas' container registry here that is hosted in GitHub, and that's basically, I'm impersonating him a bit. Just for the sake of simplicity. Is that correct?
Yes, that's
all
fine.
right. I will be using your credentials.
I'll allow it.
Okay. Can I have access to your credit card as well? So that's pretty much it. What I'm doing here is that now func is building that using build packs again. Build packs, if you don't know about the projects, definitely check it out. The idea here is just to allow people more from the operation side to define how your application should be containerized. And that basically removes from the developer all the mistakes that you can make when you're writing a Docker file, right? Like having security issues because we are using the wrong base layer, just having some crazy scripts running stuff that you shouldn't be running when you're building your images, or leaving stuff in your final container image that you don't want to have in there when you're running it in a production cluster. So that, again, take a look at that. And finally, it's pushing the function there to the registry. This is going to depend on the internet connection here, but now it's actually deploying the function to the cluster. And at the end of the day, the only thing that I care is just having a URL there where I can just call the function that I've just created, right? So I have that function publicly available here, and I can, again, just call that and just get the result back, right? That's exactly what we had. With that in mind, I think that we are ready for just looking into a bit more advanced stuff.
Yes, that's great. So we closed the loop. We got from code to URL. And we saw an example using the func CLI with Go. But as Mauricio said, it works with different kinds of languages and frameworks. It works specifically for Spring also. So we're going to move and talk about how to build functions with Spring. So if we consider again the different aspects that we mentioned earlier about serverless applications, one important aspect was the cold start part. So we don't want to have applications running if there's no request, if there's nothing to handle, if there's no work to do. That means that if we scale to 0 and then a request arrives, we have to be fast in starting a new function. In the Java ecosystem, we have GraalVM, an amazing project that lets us build native executables. So instead of compiling the application traditionally into bytecode, that then the JVM transpiles into machine code at runtime, we directly build an executable directly using the machine code. That brings us several advantages. In the Spring ecosystem, we have the Spring Native project, which brings in support for GraalVM. At the moment, it's a separate project, and starting from the next major version that will be released later this year, it will be fully included in the main Spring Framework and Spring Boot projects. First benefit, we get almost instant startup time. That's what we want when we deal with functions. We also want instant peak performance. So the function should be up and running quickly and be available and ready to process some requests or events. And then we also get reduced memory consumption. So we want to have these auto-scaling features, but we also need to consider how many resources we need to support that auto-scaling capability. So reducing the memory consumption is a key part of this. Of course, there's no silver bullet. We should consider the trade-offs. And in this case is that at the moment, the build involving GraalVM, so building native images, is a bit slower and heavier than a traditional JVM build. This is getting better and better with newer versions of GraalVM. And in the last version, they also introduced support for Apple Silicon computers, and that's even faster to build, so it's pretty impressive. And there's also fewer runtime optimizations. The JVM dynamically can infer some optimizations at runtime. Since with GraalVM we move all that analysis at build time, we have fewer optimizations. But again, the project is catching up very quickly. Having solved that, we need to implement our functions. Again, we want to focus on the developer experience and have developers focus on the business logic. And we can do it by simply adopting the functional interfaces provided by the standard Java language, introduced in Java 8. We can use suppliers, functions, and consumers, and implement our business logics in terms of these interfaces. So that's plain Java, standard Java. And these functions, we can implement them. Basically, we can use any kind of framework or backend service we want to support these functions. What is important is the signature. We are using these interfaces, and by aligning with these interfaces, we can then take advantage of Spring Cloud Function. Spring Cloud Function is a great project for adding on top of our functional implementation a lot of different services that lets us expose and consume functions in different ways, using different protocols and in different environments. It provides transparent type conversion, which is not available in Java when you compose functions together. you have to take care of ensuring that the output type of the first function is compatible with the input type of the second one. This happens transparently with Spring Cloud Function. We can also use or define multiple inputs and multiple outputs. We have the possibility to write and combine together imperative and reactive functions in the same application. And we can even embed functions, standard Java functions that have been implemented and tested somewhere else, packaged as jar files, and then embed that jar file into an application with Spring Cloud Function. So let's have a look at the demo now. So I'm not going to start from the func CLI. It works in the same way. You have already seen that, but it works the same way with Spring. So instead, I'll go through a different way here. So we'll go from start.spring.io. I'll create a new Spring project with Gradle, Spring Boot 267. The application, let's call it web function. And the only dependency I need is Spring Cloud Function. I have already opened the project in IntelliJ, so let's move there. And there it is. All right, so we have the main method here where the application is initialized. So I can start by defining what kind of business logic I want to implement. And I want this function to do exactly this. As input, I provide a musical instrument name, for example, piano. Then I want to convert that string into uppercase, like this. And finally, I want to build a sentence. Let's say, I play and then the name of the instrument, all in uppercase. So let's start building that. Once again, I'm going to use standard functional interfaces provided by the Java language. So I'll define a function. The input is a string, and the output is a string. Let's call it uppercase. And import the interface. And this function, so let me add a logger here so we can follow what happens. Yes, get logger. All right. So the implementation of the function, we have an instrument name as input. And for the output, first I'll print a message, info, so converting something to uppercase, and then the name of the instrument. And then I return instrument.toUppercase. So that's the first function. Now the second part of the function will be actually implemented by second function. So I can show you how to compose multiple functions. And just because I can, I will make this a reactive function. So I'm going to have a mono of string as input and a mono of string as output. String mono is a reactive type. You can associate it to an optional. It means at most you get one item, one piece of data, but asynchronously. So if available, when available. We call it sentence. And once again, we have the input, it's a mono of string. And then we can say that we get the instrument string. And then we do two things. First thing, building sentence for, and then the instrument name. In this case, it will be the one all in uppercase. And then we return the final sentence. I play and the instrument name. That's it. So these are two functions. There's nothing about the framework here. It's pure Java. Now, in order to have Spring Cloud Function as all those extra features that I really like to have in place, I will define them as beans. That's all I need to do. Now, the framework knows that I wanted to enhance these functions. And the final piece of configuration or information I need to provide the framework is what is the function, that the overall function, we can call it the cloud function, that the framework should handle. And since I want to compose uppercase and sentence, I can go in the application property file and say Spring Cloud function definition. And I use a very convenient syntax here. I can say uppercase, pipe, sentence. So now the framework will handle a cloud function, which is composed of uppercase and then sentence. And since the two signatures are not compatible, the framework will also take care of converting a string to a mono of string. At this point, we can run the application. And you can see implicitly now the framework will expose this function as an HTTP endpoint via the root endpoint. So I don't have to do anything myself in that regard. So the application is running on port 8080. Perfect. And then I can say HTTP on port 8080. It's a post request to the root endpoint. And to pass a request body, I'll use this echo piano.
Make it bigger.
Let's see if I can.
No?
No? Then let's move it here so it's bigger. Yes, we have a request body with the instrument name. That's the input to the function. The root endpoint is what is the one used to expose the cloud function. So I send the request, and I get back the response. I play the piano. And that was it. So I really had the chance to focus on the business logic, and then the framework takes care of the rest. It was a simple example, but we saw how to compose two functions, uppercase and sentence. We did this data processing. We experienced transparently the type conversion that the framework takes care of doing, and we also got the function exposed via an HTTP endpoint. But Spring Cloud Function can do more than that, because you can add some adapters in order to deploy the function on Azure Functions, AWS Lambda, and Google Cloud Functions. Or directly as it is now, you can containerize it with build packs using the func CLI maybe, and deploy it on Knative. You can even take advantage of the CloudEvents specification if you want to deal with events rather than HTTP requests. And it really doesn't have to be HTTP. For example, you can use RSocket, a binary reactive protocol.
That's pretty cool.
Yes. Now that we know about function, let's see what we did for the game, how we use functions in the game. Yeah.
Let's do it. And I think that before even going into the architecture, I think that just to recap, right? Like we have seen in one side that we can use Knative in order to deploy containers into Kubernetes in a very simple way. Then we took a look at the func CLI that basically allows us to go from creating a project to building, containerizing a project, and deploying that into a Knative, setup as well. And finally, we have looked at some tools that you can use as a developer to just build functions in a more natural way, right? Like again, here you're not using, for example, REST controllers just to expose different endpoints. You are defining, using Java functions, pretty simple functions that can be, aggregated and reused in different places. I think it's important to mention also that we are moving here under the assumption that your applications are going to be containers. That's why we are running them in Kubernetes. That's the main thing that we are running here. And then you can start thinking about that, about how many functions do you want to run in a single container. That's a very valid question. And I think that Spring Cloud Functions is doing a great job there, allowing you to expose multiple functions in the same application and providing a bunch of other mechanisms that we haven't showed about how to route, for example, events to different functions that are all running in the same container. So that idea of having a function per container is something that you can do, but you can also go beyond that and have multiple functions there as well. And the frameworks and the platform will take care of that. For the game that we are going to be playing, the thing that I showed at the beginning, we wanted to go a little bit beyond the hello world, because it's cool to show like hello world's pretty simple stuff, but when you start actually building an application, then things get messy really, really fast, and it goes really, really bad super fast. So I'm expecting the demo to fail in some way or another, but we will try to play it all together. So the architecture, it's pretty simple, but again, it has its complications. The first thing that we did is we created a React application that's on the client side. It's going to be interacting with something that we call game front end, but it's inside the Kubernetes cluster, running there as a Knative service. This is the only service that is exposed outside the cluster, right? So the client code that you're going to download to your phones is going to be sending requests only to that service that is exposed, right? That service that has kind of like the orchestrator tag in there, it's called orchestrator because in this case we are using HTTP functions. That basically means that we need to decide which function are we going to call next. And the logic for deciding that, it's encoded in, in that backend, in this front-end application that is running there in the cluster, and that the clients are hitting, right? So as you can see, we have different kind of functions, but the main ones are, we have like a start game function that goes to Redis and say there is a new player here playing, and these are the details. This is the nickname. This is the when it started playing and all that stuff. And then the level functions, right? Like if we want to create like 10 different levels, we will just create 10 different functions in there. We will have 10 different containers that are going to only be started whenever someone is playing at them. All of them, they are going to go and write the score to Redis in a synchronous fashion, in this case. That basically means that whenever we want to send the score to be evaluated to a function, we will need to wait the function to store the score in Redis in a synchronous way in order to get the score back to the application and to your front end. And finally, we have another function there that is called getLeaderboard, that is basically dynamically going to Redis and looking at all the levels that you have played and all the scores that you have gotten in all the levels and building an entire list of all the players that are playing at the application at a single time. By just building this, you face a bunch of challenges, and all of the challenges that we mentioned before, right? Like latency will be one, cold starts are going to be the other one. The good thing about this is that every function in the game can be in a completely different language as soon as we use the same interfaces for that. As soon as we define what a function level is, we can just use the same types in different languages and just build, the levels in any language that we want. And we actually did that. We have some Go functions, we have some Java functions in there. They all work the same. They all interact with Redis. So in this case, for this demo, as I mentioned before, we are using kind of like this more synchronous pattern where we are just interacting by sending the functions an HTTP request. And functions will be created whenever we are just calling them. That's pretty basic, and that's kind of like what we have been showing. We definitely need an orchestrator if we have these kind of functions that require someone deciding which function to call next, right? And again, the game logic is in that game front-end application that basically takes requests from the client and then decides which function to call next. That's something that you need to take care, just have in mind when you are designing these applications. You will need to have a way to describe that logic in a way that it can be maintained and it can be extended. Synchronizing a state is hard. And again, that's something that comes with this programming model. If you want to share a state across different functions, then you need an external storage, you need some caching, you need to have an efficient way of accessing this state. Making sure that the data store is not the bottleneck, it's the most complicated part of building these kind of applications, because if we start scaling the application up, we have tons of replicas for all the levels. At some point, we will reach the maximum number of connections that we can get against the database. Our application will start crashing all over the place. There are some techniques to avoid that kind of stuff. One is doing writes to the database in an asynchronous fashion, maybe using events, maybe using like a more reactive approach to writing into the database. And that usually leads us to that latency can become a problem if we do synchronous requests. And if we start using more like an asynchronous pattern, then we will need to deal with eventual consistency issues in our application. And that's not like an issue per se, but it's something that you need to have in mind when you are designing this kind of stuff. Which leads us to the next stuff, which is more the asynchronous side of things.
Yes, usually when talking about serverless, events are always there. We haven't talked about them really so far, so let's try to see how we can introduce events now in this architecture. So far, it's pretty synchronous. It's based on HTTP requests and responses. And Knative has a solution for that as well. So we talked about Knative Serving that allows us to build a serverless platform on top of Kubernetes. Knative Eventing follows the same guidelines. So, for example, providing more developer-friendly abstractions in order to allow us to build not only serverless architectures, but also event-driven architectures. And it does that by defining a standardized way of doing event routing. So we might have different routing system, different message brokers in our infrastructures, maybe different teams. Some teams are using RabbitMQ, some teams are using Kafka, and in some cases, events are really not something that we send through a message broker. Maybe an event is something that happens on Twitter. For example, if you want an event, every time someone posts a tweet with a specific hashtag, or it's something, an event could be a message from Slack, from a Slack channel. So for that reason, Knative Eventing adopts a standardized way of exchanging data as events. And the standard is called CloudEvents. So this provides polyglot support, so we are not really limited in what kind of technology we can use. We have a common abstraction, but then below this abstraction, then we can use all our favorite tools. But then the system overall has a standard way of exchanging this data. And CloudEvents is what we use in Knative. Again, it's a pluggable architecture. We have abstractions in Knative Eventing, but then we can plug in RabbitMQ or Kafka, for example, Redis streams. And finally, once again, it's cloud-agnostic, just like Knative Serving, because we can run it on Kubernetes. It runs on any Kubernetes distribution, and it's not really specific. We don't have limitations in that regard. A cloud event is a simple data structure. We have some metadata that are really important to identify and route events. And then we have a payload that could be anything we want. It could be a JSON object, but it could also be an AMQP message, for example. So you could use Cloud Event to transfer an AMQP message that may be originated from RabbitMQ somewhere else, but in a standard way. You can use it with Kafka, MQTT, and so on and so forth. Now, a pretty neat thing about Spring Cloud Function. So without changing anything, I believe I still have the application from before still running. Yes, it's here. So Spring Cloud Function supports Cloud Events out of the box. Cloud Events can be transferred in different ways. One way of transferring Cloud Events is over HTTP, because it's really a standard for data formatting. It's not a protocol. So I can use HTTP. And in order to make a request following the Cloud Events format, I need to add some headers. One is the ID of the event, for example, 21. Then I need to specify the type of event. Let's say this is a greeting event. And then the source devox. And there should be a column.
There you go.
And then, so all the metadata of the Cloud Event are provided as HTTP headers. And the payload of the Cloud Event is the request body. Let's see. I got the same result in the body, but now Spring Cloud Function interprets and handles this request as a Cloud Event object. So you can see that we also get back the Cloud Events headers. And that's what we use for the game. So yeah, let's have a look at that now.
Yeah, and I think that's something important to mention there, is that because now we are dealing with Cloud Events, then we can use all these headers and all this metadata that Cloud Events specification is providing just to route events in different ways. So as soon as we have some intelligent routers that understands how to create filters and how to route events to different places when we need that, we can just start wiring different functions that are, for example, emitting events. And that's what we kind of like did for the demo, and we will be showing that when we play all together. The idea here is that you have a Kubernetes cluster, you install Knative Serving for dealing with the auto-scaling and for dealing with functions in this case that will be bootstrapped on demand. But we also install Knative Eventing that brings some other Kubernetes objects like, for example, brokers and triggers. Brokers and triggers are only there because we want to support the concepts of producers and consumer of events, right? And we want to use routers, which are brokers, and triggers that are more like a subscription to say, hey, this application is expecting this kind of events. So if you see one event of this type, let's forward it to this instance of this application. If we want to basically copy events and send to multiple places, we can do that as well. For this simple demo, what we did is that we enable each level function to emit a cloud event, as I mentioned before. So we are calling the function using an HTTP request. The function is doing some calculations and emitting an event, and that event goes to the broker. And an important detail there is that in order for the function to send that event to the broker, it doesn't need to know which message broker implementation we are using down there, right? We can be using Kafka, we can be using RabbitMQ. For the function, it doesn't matter. The function, the only thing that it will do, it will send an HTTP request from the function to an HTTP endpoint that the Knative Eventing broker is exposing. Knative Eventing, the broker implementation that we have chosen, can be RabbitMQ or Kafka or a cloud provider specific one, will take that HTTP request and just pass it down to the actual implementation that we are using. Once the message is there in the broker, then we can define triggers. And in this case, we have defined a trigger. Again, it's a subscriptions to say, if we get certain type of events, in this case, like the score events that we are generating in the function, we want to forward that to the game frontend, which is, again, the main entry point for the application. And that game frontend is going to propagate that cloud event to your client application, in this case. We will only see this for the leaderboard. We wanted to create a more reactive leaderboard that basically shows us every time that somebody completes a level, it will just push a cloud event using our socket. Our socket is a pretty cool technology, so you can think about like the evolution of using just plain WebSockets, and it's something that provides you bidirectional connection between your application and the backend. It's pretty nice, and it works pretty cool, and it's very well integrated with Spring in general. Some takeaways about using eventing in these kind of scenarios is that you can start extending your synchronous application with a more event-based approach, building more reactive features on top of it in a very simple way, without putting the burden into the developers to understand and include libraries for connecting to RabbitMQ or for connecting to Kafka. The moment you start adding these libraries to your applications, then updating the infrastructure, in this case, that is required for running your application becomes more complicated, and Knative Eventing is coming to solve that same problem. As we mentioned before, you install Knative Eventing into a Kubernetes cluster, and then you can have one or more implementations of message brokers. You can have Kafka, RabbitMQ, Google PubSub running at the same time, and then just send events to these different brokers if you want to. For developers, again, they are only sending HTTP requests. They don't need to care about the underlying infrastructure. All the Knative Eventing components deal with cloud events, so we can filter based on metadata using this standard format, which gives you, again, the possibility of writing each of these different levels into different languages. And we will go faster. Monitoring for this kind of applications is really important. And again, eventual consistency is a thing. Because we are running out of time, I think that it's time to play. Yes. If you scan this with your phones, you will open the application, and you can start playing there. You can also start playing while I open the leaderboard. I will not open it until you do that.
Yes.
So we will put a countdown of 30 seconds for you to open and start playing. Yeah.
And then we'll play too. Yes.
And then we will just play as well.
Yeah. Let's have some fun.
If you are the first hitting the application, of course, it will take longer because the functions will need to start.
Yes. So you'll experience what happens when we scale to 0. Yeah.
Exactly.
Yeah.
All right. You're there?
Yeah. Then
just open the leaderboard.
Yes, and then you can move the leaderboard.
Exactly. Yes.
Yeah.
There you go. So if we go here while you're playing, bring back Danish keywords. Let's see if this works. It is not working, but I guess that's not the right URL. Oh yes.
Yes, that's it.
There you go. So basically what's happening now is that the application is receiving cloud events, it's updating the state. And it's good because we have a bunch of people playing there. Look at that. Whoa. That's pretty cool. Go for it, man. Okay. That's pretty much what we wanted to show. I guess that to close, we will be looking at Twitter. So if you tweet the scores when you finish the 5 levels that are created there, we will have some codes for some books. And yeah. And feel free to get in touch, Twitter or in any way you want. There is some code there if you want to get access to the books. Yeah, the 2 books. And yeah, feel free to get in touch. This is us. Right? That's it.
Yes. Thank you. Thank you for joining. Hope you had fun.
Thank you.